All right, so we got a couple new gas laws to add in to what we already have. The first one is Avogadro's law. So we're not actually going to spend a lot of time on this. You will use it. Right, so you got V over N equals another V over N. You got primary conditions and secondary conditions. But that N is going to be the amount of gas in moles, as you can see down here. And the idea is that if you had two gas samples and they had the exact same temperature, pressure, and volume, they would also have the same number of particles, right? And that number of particles, according to Avogadro, for 1 mole will be 6.022 times 10 to the 23rd. So that N, and that's moles, is connected way back to what we talked about before, right? So moles of gas, the amount of gas obviously affects the volume, right? If you blow air in a balloon, it's going to get bigger. If you let air out, it's going to get smaller. So these things are definitely directly proportional. And you can use this equation to solve some questions, and you're going to have to. But otherwise, once I add in moles to pressure, volume, and temperature, I finally get to this ideal gas law that I'm going to use. There's actually pressure, volume over moles times temperature, right? I have it set up this way because it kind of looks like my combined gas law, which was PV over T equals another PV over T. But instead of having secondary conditions now, we're just going to use these four variables and then a new thing, a constant that's going to be derived. So I'm going to have this constant value, we're going to call it R, that we need to calculate here. And we use this molar volume down below, so it's actually fairly simple. It's pretty easy to figure out. If I have a gas at STP, 1 mole of it should have this volume of 22.4 liters. So my pressure at STP would be 1 atmospheres. 1 atmosphere, we know that. My volume would be 22.4 liters. My amount of gas, as stated down here, would be 1 mole. And my standard temperature is 273 Kelvin. If I plug in those values and I multiply and divide, technically I only have to take that 22.4 and divide it by 273. That's going to give me a value of 0.0821 with 3 sig figs. And that value is going to be what I use every time I see R for these gas law problems. So 0.0821 is my R value, my constant that I'm going to use. It does have a label, atmospheres times liters divided by moles times Kelvin. It's a complex unit because nothing canceled out over here, right? But the reason I need to have this unit, at least in my notes, I don't have to write it every time I use 0.0821, but the reason I need to write it down at least once is because you need to know if you're going to use this value for R, you have to have atmospheres, you have to have liters, you have to have moles, and you have to have Kelvin. You can't use a torr value for your pressure when you're using this R as your constant. So again, this is my law that I'm going to use for some problems, but that's not necessarily how I'm going to write that equation typically. It's usually going to be listed as PV equals nRT. I've just rearranged some things. And normally you would want to plug into this and then solve for whatever's missing because it just makes the algebra easier. You just have to divide away from your x, right, when it's all said and done. So whatever's missing, divide those other things away, and you can solve for that missing value. So make sure that you have this version of the ideal gas law written in your notes. Otherwise, this version can be useful. It's just useful to come up with all of our other laws, because if you have just pressure and volume, they're multiplied, right? So you can see all of our other laws in there. You can see Charles' law, Boyle's law, Gay-Lussac's law. You can see Avogadro's law. So it is useful to have it written this way, but we're actually going to use it with that PV equals nRT. So I'm going to do at least one example with you guys for, so a new example for the worksheet that you're getting in class. So number 1 on that ideal gas law worksheet, I can work that out with you guys. Essentially, I'm given, right, it says how many moles of gas are contained in 890 milliliters at 21 degrees Celsius and 750 torr. So I'm given these values. I'm given a volume that's 890 milliliters. There's 4 sig figs, so I should write that extra 0. I have a temperature that's going to be 21 plus 273 would be 294. I lose that sig fig, so it's just going to the ones place. This has 3 sig figs, Kelvin. I'm going to have a new pressure here, right? I can't use the 750 torr, and I really can't use this 890 milliliters, so I'll write this 750 torr, but I'm going to have to convert it into atmospheres, right? Because if I'm going to use my R value, that's always 0.0821, you always have this. You don't necessarily have to list it, but its units are atmospheres times liters divided by moles times Kelvin. So I have to have Kelvin, which I already do. I did that already. But I need to change this milliliters into liters. So move the decimal, it just becomes 0.8900 liters. Whereas this is a little bit more complicated. I need to divide by 760. So let me do that on a calculator real quick. 750 divided by 760 is going to be 0.98684, but I'm going to round it to 4 sig figs. So I'll just do 68. I'm going to leave that 4 off, atmospheres. And now I can start plugging things into an equation, because all I want to know at the end of the day is what is my value for N. So I have that PV equals nRT, so pressure, which is 0.9868 atmospheres, times my volume, 0.8900, is going to be equal to N, which is my X, right? So I can put it in an N, I can put it in an X, times R, 0.0821. It does have units, but I'm not going to put them in there. And then times temperature, so 294 Kelvin. So I plug in those values. I just divide away from that N to solve for it. So at the end of the day, N is going to be 0.9868 times 0.8900. And then I'm going to divide by 0.0821. And then I'm also going to divide by 294. And that's going to give me an answer for N, which happens to be really small. So maybe I should check that. I don't know if I hit that in the calculator right. 0.9868 times 0.89 divided by 0.0821. divided by 294. Nope, it is definitely supposed to be small. So I get this answer of 0.0363855 on my calculator, right? I got to round it to 3 sig figs because 0.0821 only has 3 sig figs. 294 does too. But my final answer for N is going to be 0.0364 moles. So all you do is list out what you know, solve for that one thing that's missing. You're always going to know it's an ideal gas law problem because you're not going to have 2 of anything. They're just going to tell you 1 volume, 1 temperature, 1 pressure.